In this video, I wanted to go over special triangles and how to apply them. So there are two special triangles that are necessary to really remember. I always try to put them to memory so that I never forget what to use. So these are special right triangles, and one is the 45, 45, 90. And one is the 30, 60, 90. So these special triangles will appear a lot in both geometry and trigonometry. So it's always good to just remember the sides, and that's what I call the base triangle. So all 45, 45, 90 triangles will have sides proportional to 1, 1, square root of 2. So you've probably already talked about this 45, 45, 90 triangle. It's an isosceles triangle, right? That means both legs are the same size. So that makes sense that all 45, 45, 90 triangles would have some proportion of the legs being the same, 1, 1, square root of 2, and the hypotenuse is square root of 2. So what I like to say is that they are all related to what I call n, the multiplier. So every 45, 45, 90 triangle is going to be proportional. So it could be bigger or it could be smaller, but all of those sides are going to have the proportions of 1, 1, square root of 2, meaning I can multiply this base triangle by a multiplier n. And every 45, 45, 90 triangle would be multiplied by n from the base. So let's do a quick example. Let's say we needed to know, we were given that this was a 45, 45, 90. And if you're only given one triangle, you know it's a right triangle. And if you're only given one angle, then you know the other one has to be 45, right? The other two will have to add up to 90. So if you were given a triangle, and let's just say you were only given one side, and it wanted to know this side and this side. Well, immediately you know that, okay, the 2 is the one side, meaning what have I multiplied 1 by to get 2? So we would say 1n. I've multiplied the base triangle by something to get this same leg, to get this same side. So in this case, this example, they've given us 2, meaning 1 times what equals 2? Well, that means n must equal 2. So if we go up here, and if our n equals 2, that means I've multiplied the other two sides by n as well, because 45, 45, 90, everything's proportional, meaning I can make the sides longer, but the angles remain the same. So I've multiplied, if I multiply square root of 2 times n, and we know n equals 2, well then this hypotenuse must be 2 times square root of 2. So the n equals 2, so I've multiplied that hypotenuse by 2. So just square root of 2 times our multiplier, which is 2. The other side, we know in a 45, 45, 90, it's isosceles, the two legs have to be the same. So we immediately know it has to be 2. But we could also think about, okay, I know it's a one side as well, and I multiply it by my multiplier, which is 2. So in that case, that would just be 2 as well. So that's how we can use the base triangles with our 45, 45, 90 special triangle. And just as a real quick review, the reason that this works out is because if you remember in geometry, we can have to prove congruence. If two triangles are congruent, that means all sides and all angles are congruent. And if you remember, we have all of those acronyms that we can use to prove congruence. But if we remember, angle, angle, angle is not one of them. And that is because of this exact thing. I can have proportionally the same angles in these two triangles, but obviously they are not congruent because I can stretch each side the exact same amount proportionally. And that's exactly what n is. N is that proportion, meaning all 45, 45, 90 triangles are proportional by some multiplier n. And the base triangle is 1, 1, square root of 2. So I always just like to point that out to relate it back to our what we've learned in geometry. And we also learned that similar triangles, right? These two triangles would be similar, and angle does prove similarity because of this proportionality. So they are still proportional, all sides are proportional, and the angles would be the same. So angle, we call it angle because obviously the third angle would have to be, they have to all add up to 180. And in this case, if it's a right triangle, that third angle would have to add up to, or the other two angles have to add up to 90. So that would be, if you just have two angles that are the same, we automatically know that they are similar and they are proportional. So these are just the two special triangles again. So 45, 45, 90 is one of the special triangles. The other special triangle is 30, 60, 90. So the two sides of that are across from the 30 is the smallest side. We know the smallest angle has to have the smallest side directly across from it. So that is the one side. Then I remember that the hypotenuse is the biggest, and it is just 2. Then across from the 60 is the square root of 3 side. So this one is a little bit different. 1, 2 square root of 3 is how I remember it, remembering that the one side is across from the 30. And we'll learn a lot in trig that 6's and 3's go together. So if you remember, or if you've been taught this, 60 degrees is the same as pi over 3. 30 degrees is the same as pi over 6. So I often remember 6's and 3's go together. So in this special triangle, across from the 60-degree angle is the square root of 3. So this would be another one that I would definitely try to put to memory. So the 45, 45, 90 is 1 square root of 2, and I can multiply that by a multiplier. The 30, 60, 90 is 1, 2 square root of 3, knowing that 2 is the hypotenuse and is the biggest. So if I think about that, 2 has to be bigger than the square root of 3 because 2 equals square root of 4. And square root of 4 is certainly bigger than square root of 3. So my hypotenuse has to be the biggest side. So that has to be the 2 side. And the square root of 3 goes across from the 60. So those are all tricks to remember these special triangles. So same thing, every 30, 60, 90 triangle is going to be proportional from this base, 1, 2, square root of 3. So again, if I were given a triangle where even if I only knew, so let's change it up a little bit, if this were my 30 side, this might be a little bit challenging, but if I were given, let's say this is 2, and I needed to know the other sides. Well, I know that this across from the 30 is really my one side. So it's a little bit different here. We've changed up the orientation, and that's okay. We still know this is a 30, 60, 90 triangle. So they've given me this, and they want to know the other two sides. So again, I know that across from the 30 is my one side. So that means this has to equal my 1 times my multiplier. So again, in this case, n just has to equal 2, right? I've just multiplied 1 times what equals 2, n must equal 2. So I can go back to my other sides and say, okay, well, this side is across from the 60, so it has to equal square root of 3 times n. And my n is 2. I already know what my multiplier is. So in this case, that side would just be 2 square roots of 3. Then for the hypotenuse, we know that that has to equal 2 times n, and my multiplier is 2, so that would be 2 times 2, which would just be 4. So that way I've solved all the other sides, only given one side. So that is special triangles and how to remember them. If you have any questions, feel free to comment below.